Hello, and welcome to this lecture video on the use of variables, equations, and formulas in business. Formulas and equations show mathematical relationships using a combination of numbers that are constant, mathematical operators, and variables. Variables in a math expression represent quantities that can be changed when solving the expression. They are often represented by lowercase letters like x, y, or z, although variables can also be capital letters like A, P, D, T, S. Any letter can serve as a variable. Although as you go through your studies in your different fields, you'll find that certain letters mean certain things within your fields. So you'll use, for example, T in some fields to signify time. And you would not use T in that case for something that did not signify time. Where variables appear in formulas and equations, they are places to plug in different values. So they are where you substitute in different values when you actually solve the equation or formula. So far, we have been working with expressions like this one, 6 divided by 2, which has no variables, only numbers and the division operator. And it means one thing, it means 3. 6 divided by 2 equals 3. Now suppose we use a variable to write a similar expression. Suppose we write the expression x divided by 2, which has an x variable instead of the 6. Using it, you can take x to be 6 by substituting 6 in where x is, and you get 6 divided by 2 equals 3, which is where we started. What have we gained by using x instead of just writing 6 divided by 2? We have gained flexibility. We've gained flexibility to use that expression again in another situation under other circumstances. Suppose that instead of 6, x equaled 7.8. Substituting 7.8 in for x in x divided by 2 leaves 7.8 divided by 2, which is 3.9. Using variables allows us to make flexible mathematical expressions that can be applied to a multitude of different situations. This is why they come up so very often in the application of math. As you move ahead in the study of business, use of mathematical formulas and equations will arise in all fields. So equations and formulas are kind of the same thing. An equation is a mathematical expression that has an equal sign in it. So there are things on the left and things on the right, and they are set equal to one another. That's what an equation is. Formula is used in a more specific way often. It is used to signify an expression that is there to calculate a particular quantity. We'll see examples of this. In finance, marketing, and supply chain, among other fields, you will learn to use linear regression analysis, which is a type of statistical analysis. You'll use it to do forecasting and to gain insight into existing trends and patterns in data that you are interested in. Linear regression analysis is an advanced topic. But the thing is, it's based entirely on straight lines that are defined by linear equations that you are likely familiar with in the form y equals mx plus b, which is the most basic form of linear equation. That is the equation of a straight line. In that equation, y and x are variables. But when you actually go to use this equation, y equals mx plus b, you would have numerical constants to substitute in for the m and the b to get a particular line in space. Now there's a footnote on the variables. Let's see what that's about. Note that once you start employing variables in your expressions, the multiplication sign, the x operator that we're used to, stops being used almost entirely. In the equation y equals mx plus b, the fact that m is multiplied by x is shown simply by the letters being put together, put next to each other. Some formulas and equations will use serial parentheses or an asterisk to show multiplication. So serial parentheses, an example is r plus 1 times c plus 1, which means to multiply r plus 1 by c plus 1. The asterisk is used often for multiplication, especially in business, because that's the operator that Excel uses. And so people use it in lectures and talks all the time to signify multiplication. B asterisk x means multiply b times x, whatever b is and whatever x is. So what are some things that can be done with equations? They can be used to solve given certain values. This equation y equals mx plus b is written in a way in which it is easily solved given an x value. Actually, y equals mx plus b is the slope-intercept form of the equation of a line because it gathers the slope and the intercept along with the x variable on the right-hand side, so you can just plug in an x and get out what y is. When you have an equation that has two variables in it like this, you can solve for either one. So we'll go through how to solve an equation with two variables for one of the variables. Then we will use this equation calculated in part B to find out what x is given certain values of y. Example 7.1 says, you are given the equation y equals 2x minus 1. So we could observe that the equation we're looking at is of the form y equals mx plus b. And there are all kinds of implications to that, but we actually have a whole nother section dealing with those implications. So let's just stick with using this as an equation of two variables. Part A says use this equation to determine what y is when x equals -1, when x equals 0, when x equals 1/4, and when x equals 2.5. So this is reminding us that we can use an equation like this on any type of number. We can plug in a negative number, we can plug in a 0, we can plug in a fraction. This x equals 1/4 we could plug in as a fraction, or we could plug in its decimal form. If you divide 1 divided by 4, you get 0.25. In order to gather our results, I'm going to just build a little table. We're going to be plugging in values of x and calculating values of y. We want to start with x equals -1. So when x equals -1, what does y equal? How do we handle this question? When x equals -1, y equals 2 times x minus 1. So we plug -1 into our equation. The equation says y equals 2x minus 1, so 2, and I'm just going to use my parentheses here. I'm going to plug in -1 for x. This expression, as I've just written it, means 2 times -1, and subtract off the 1. 2x minus 1. Now this is something that you can put into your calculator, right? In a calculator, the multiplication has precedence over the subtraction, so you don't even have to have any parentheses in it. You could put 2 times -1 minus 1, and what you'll get is -3. How about when x equals 0? When x equals 0, plug 0 in for x. Y equals 2 times 0 minus 1. You can certainly use a calculator for this, but you can also use the fact that 0 times anything is 0. So 0 times 2 is going to come out to 0. That's going to give you 0 minus 1, which means y equals -1. So when x equals 0, y equals -1. Now, if you're feeling comfortable with this, go ahead and pause the video and calculate out the other two. So given the equation y equals 2x minus 1, when x equals -1, y equals -3. When x equals 0, y equals -1. When x equals 0.25, y equals -1/2. And when x equals 2.5, y equals 4. This equation can be solved for any value of x. And as we'll see in a later section, this equation could be graphed and it would be a straight line. Now we're asked in part B, solve the equation for x. So we're given y equals 2x minus 1. The steps I'm about to take can be done in many different orders, but the idea that we're going for, whichever order we take, is that we want to get x alone on one side of the equal sign, just as y is alone on one side of the equal sign right now. So solving the equation for x means getting x alone on one side of the equal sign. So let's start that process by getting the 1 to the other side of this equation. to get the 1 to the other side of this equation, we need to add 1 to both sides. So the deal is with equations like this, you can do whatever you want to them in terms of dividing, adding, subtracting, multiplying, as long as what you do is done the same to both sides. Doing the operations the same to both sides keeps the equation equal. So in order to get this minus 1, or subtract 1 off of the right-hand side, we need to add 1. Adding 1 to both sides on the left side is going to equal y plus 1, rewriting. And on the right-hand side, the minus 1 cancels out the plus 1. They add up to 0, which leaves only 2x on that side. Now, because I like my equations to have the variable for which we're solving on the left-hand side, I'm going to rewrite this equation with the 2x on the left side of the equal sign and the y plus 1 on the right-hand side of the equal sign. Now, the final obstacle between us and solving for this x is the 2 that the x is multiplied by. In order to get the x alone, we're going to have to divide out that 2, because 2 divided by 2 is 1. If we're going to do that to the left side, we have to do it to the right side as well. Y plus 1 has to be divided by 2 as well. So on the left-hand side, the 2's cancel. 2 divided by 2 is 1, and 1 times x is just x. And on the left-hand side, you have y plus 1 over 2. Now, when you have two numbers added on the top of your fraction, both over the same denominator, they can be separated out. So y plus 1 divided by 2 can be written as 1/2 y plus 1/2. Dividing a quantity by 2 is the same as multiplying it by 1/2. So here we're just distributing the 1/2 over y plus 1. But the answer here is x equals 1/2 y plus 1/2. Part C of example 7.1 says use the equation from B to determine what x is when y equals negative 2.1, y equals 0, and y equals 5.9. Once again, I'm going to build myself a data table, and I'm going to put x on the left and y on the right because that's alphabetical order. We have this equation and these values of y to plug in. When y equals negative 2.1, what is x? X equals 1/2 of negative 2.1 plus 1/2. Now, calculating this out with a calculator, it is easier to use 0.5 instead of 1/2. So you could do 0.5 times negative 2.1 plus 0.5. And what you get is x equals negative 0.55. So x equals negative 0.55 whenever y equals negative 2.1. In a later section, we will be graphing things like this. The x and the y would be coordinates on our graph, and a dot would appear at those coordinates. If you have the idea, go ahead and pause the video and calculate out the rest. So when y equals 0, x equals 1/2. We could write that 1/2, or we could write that 0.5. And when y equals 5.9, we find that x equals 3.45. So these are going to be points along the same exact line as represented in the equation in part A. All we did was solve that same equation for a different variable, but it still leaves all the relationships within the equation the same.